Thank you, Dr. Zhang. Just drink some water. I'm thirsty. It's a sympathetic system. Before I begin, I just want to thank everyone for being here. Seeing so many faces supporting me right now, it's very touching, and I appreciate all of you. Thank you. Okay, so my project is studying the effects of hormonal withdrawal on prostate cancer progression. To begin, some background. What is prostate cancer? It's a cancer directly affecting men, where 1 in 7 men are expected to be diagnosed with this disease sometime in their lives. It's the second leading cause of cancer-related deaths in the United States, and this figure is actually consistent with Europe as well, where it is also the second leading cause of cancer-related deaths there. Prostate cancer is understood to be a disease of aging. Most men diagnosed with prostate cancer will actually not die from the disease. There's an estimate of about 3 million men currently living with prostate cancer in the United States. What we are interested in is the prostate cancer, which then progresses to the advanced stages and becomes metastatic. And this becomes known as CRPC, or castration-resistant prostate cancer. What is the prostate? Where is the prostate? It's a walnut-sized gland located only in men right here beneath the bladder and in front of the rectum. The prostate produces fluid which liquefies the semen. So liquefies semen, and the maintenance of these cells in the prostate is maintained by something called the androgen receptor. The androgen receptor, depicted here with all of the domains of importance, the androgen receptor is responsible for the cellular proliferation and the development of those cells. So we have the NTD, the N-terminal domain here, the DNA binding domain, a hinge region, and then a C-terminal ligand binding domain, and this is where the androgens, or the hormones, bind. Now that we understand the structural aspects of the androgen receptor, how does it work? What does it do? What is its function? The androgen receptor is responsible for regulating gene expression. And how it does that is normally it is located here in the cytoplasm, associated with heat shock proteins, or HSP, when unbound. And upon binding of androgens, or hormones, such as dihydrotestosterone or testosterone, a conformational change happens, and the androgen receptor translocates to the nucleus as a homodimer, where it binds to these promoter sequences called the ARE, or androgen responsive elements. This encourages transcription and eventually gene expression. The androgen receptor affects many, many, many different downstream target genes, and one of the many downstream target genes is something called the PSA. The PSA is the prostate-specific antigen. It is a serine protease protein that's secreted or produced by the prostate cells. This schematic diagram here represents what you would see in a cross-section of a prostate gland in a normal prostate and then with cancer. So we move over here. Normally, the PSA that's produced by these cells remains within the confines of the gland. However, when the cells begin growing and dividing at a faster rate than normal, the layers of the prostate become disorganized, and PSA will leak out into the blood. So this is why PSA, prostate-specific antigen, is used as a serum biomarker of prostate cancer progression and also androgen receptor activity as an indicator of that. Men who have prostate cancer are found to have elevated levels of PSA in their blood. How do you treat prostate cancer? The goal of treatment is to kill the cancer cells and to stop the development of the cancer. Due to the androgen receptor's crucial role in the maintenance and cellular proliferation of the prostate cancer cells, the current treatments target the androgen receptor pathway. Hormone deprivation or androgen deprivation, these are synonymous terms. that is an acceptable first-line treatment for prostate cancer. So it would make sense that you would decrease hormone and decrease proliferation. However, ADT, androgen deprivation therapy, is not an end-all be-all cure. Hormone refractory prostate cancer is able to develop, where then the prostate cancer cells are able to progress through those advanced stages independent of hormone. To give an idea of the phases of prostate cancer progression towards that castration-resistant phase, this here depicts the different stages. And on the left here, we have surgery and radiation. And this is for men who have a relatively low tumor volume or who have a local disease. But there are individual complications with this, even though surgery and radiation have been shown to be effective in treating prostate cancer. An example is that for surgery, you wouldn't only remove the prostate. There are important structures and nerves that surround the prostate. For example, the prostate surrounds the urethra, which is a tube that carries urine from the bladder to the penis. So men who post-surgery are found to have urinary incontinence. And there's also an important nerve that sits up against the prostate gland that is responsible for men being able to have an erection. So quality of life is also a big concern in men post-surgery, also with not just urinary incontinence, but also with sexual function. So not everyone elects to have surgery and radiation is the point, even though it's effective. For men who choose not to undergo surgery and radiation, or who have a relapse of the tumor, they have rising PSA levels, and they are in a hormone-naive setting, these men will now undergo androgen deprivation. Androgen deprivation has been shown to increase survival for a number of years, but eventually the cancer will progress to that later metastatic phase of castration resistance, and prognosis is very poor for men whose cancer progresses to this stage. There are a variety of mechanisms that can contribute to CRP cell survival. These include local androgen synthesis, so maintaining intra-tumor concentrations of hormone. There could also be androgen receptor amplification, so an overexpression of the AR, which contributes to increased sensitivity to the relatively low volumes of hormone present. There could also be androgen receptor mutation, which broadens the ligand binding. There could also be a change in the ratio of the co-activators and the co-repressors. So changes in the co-regulatory molecules which modulate the stability of the androgen receptor and also the sensitivity of the ligand. And there's also something called splice variants, which can be generated from alternative splicing of the androgen receptor to create many different truncated isoforms of that receptor. Of these splice variants, ARV7 is the best studied. Here is a structural representation of the differences between full-length androgen receptor on the top here with all of the domains intact and this shorter fragmented version of that receptor, ARV7, which retains the N-terminal domain but is missing the C-terminal ligand binding domain. And this is a way of ARV7 serving as a transcription factor independent of ligand. Well, let me go back to this actually, because due to the phase of withdrawing hormone preceding the phase of castration resistance, if we are able to study withdrawing hormone in prostate cancer cells, we might be able to better understand the relationship between hormone deprivation before or possibly leading to castration resistance. And studying the withdrawal of hormone in prostate cancer cells, our working cell line being LNCAP, which I'll get to in a minute, This has been performed by other students and researchers, Peter being one of them sitting in the back. LNCAP cells are an immortalized prostate cancer cell line which expresses androgen receptor and is sensitive to hormone. So Peter found withdrawing hormone in these cells, with all of the PSA levels comparable, a decrease on day 10. There were a couple caveats to this, something Dr. Zhang mentioned in the beginning or alluded to. When you grow LNCAP cells deprived of hormone, the growth rate changes and they grow slower since they're sensitive to hormone. So it's difficult to seed an exact same number of cells for such a duration since the growth rate is slower. And also the 5-day observation windows that we have, it makes it more difficult to go in and try to determine more specifically what might be going on from day 5 to 15. There's also a recent study published showing morphology in hormone-withdrawn LNCAP cells. These two, A and B, are depicting the same thing using two different neuroendocrine markers. So up on the top, we have control LNCAP cells, and on the bottom levels, we have LNCAP cells which have been starved or deprived of hormone for 5 days. And with the starved cells, you can see a change in the morphology. LNCAP cells normally are very adherent cells. They're fairly round, and they have spindle-like projections, and they'll connect to all the adjoining cells in more like a web-like manner. But neural cells have a large cell body and these fine projections. So you can see the difference between the control cells and then the ones which have been deprived, and you can see the change in the shape of these cells with the large body and these fine projections. This brings us to my project. Our aims are to investigate withdrawing hormone on these hormone-sensitive LNCAP cells, to also observe any morphological changes, and to narrow down that observation window between each collection from our preliminary work of 5 days to 2 days in order to try to see what might be going on in a shorter time span in between those collections, and to also evaluate the changes in the androgen receptor protein levels and also the activity as indicated by PSA mRNA levels. Our methods. For cell culturing, we grew LNCAP cells in regular media with fetal bovine serum, which has hormone, and we grew them to 80% confluency on 10-centimeter plates. And then we changed to either media with regular FBS serum or media with charcoal-treated serum or charcoal strip serum. And the charcoal-treated serum is deprived of basal levels of hormone, so that is our treatment in starving the cells. And then we continued to monitor the cells for 20 days for any possible changes in their cell shapes. So we did cell photos, cell counting, and then we collected the cells for Western blotting and RT-PCR. Our cell culturing timeline for 20 days, something we did differently to account for the caveats of the preliminary work is we retained total cell growth from one phase and then equally distributed that for the next growth phase. And this was to ensure that we would have enough cells to collect, first of all, for 20 days, and also enough cells to collect every 2 days, since we were trying to collect so often. So we begin on day 0 here with 6 plates, and we collect one that serves as our day 0. And is this? Oh, I found it. So 6 plates, we collect one, and this serves as our day 0. And then since we're collecting every 2 days, we return on day 2, and we have 5 plates here. We collect one, and we have 4 plates left. We are still on day 2, and we split these remaining 4 plates back into 6 plates, so that when we return on day 4, we begin again with 6 plates, collect one, and we continue this process for 20 days. Our results, we found a change in the shape of these hormone-deprived LNCAP cells, the prostate cancer cells. So here we have day 0 to 10, and these are all at 40x magnification. This is our control, our day 0, and you can see how round and adherent these cells are, maintaining each of their shapes still, but having various different projections from each cell. And then on day 2, we also noticed an immediate slower growth in these cells, where the growth seems to have stagnated. And then we have our day 4, our day 6, our day 8, and our day 10. And the changes in the shape of these LNCAP cells deprived of hormone becomes more so apparent here on day 8, where you can see this long, thin connection right here. It actually extends from here, kind of connects this cell, and then goes over here. And you can see the change in the shape of these cells persisting in day 10. And for the remaining collection period, we have day 12, 14, 16, 18, 20, and then our day 0 control again for reference. And these are again all at 40x. And you can see the change in shape of these cells with these long, fine connections persisting throughout the remaining 20 days. This was particularly interesting to us and exciting. So in order to ensure the changes we observed are reproducible, we repeated the collection again with our control set here. And you can see that these 2 rows up here are our treated cells, the hormone-deprived cells, and this is our control set. And it's depicting a similar thing, just at 10x magnification. But only in the LNCAP cells deprived of hormone do we see the morphological changes in these cells, and we do not see that with the control set. So we wanted to see PSA mRNA levels as an indicator of what might be going on with the androgen receptor. And this is an RT-PCR, and we have PSA mRNA levels, and we have GAP-DH, which is used as an internal control. So for all 20 days, you can see a gradual decrease in the PSA levels, and the GAP-DHs are comparable. So there's a change in the PSA levels, and I actually want to point out that not all of the samples would fit on one gel. So I actually had to run 2 separate gels. So the 18 and 20 were run on a separate gel with another control, and I've combined them for you in one image here. So the takeaway is that AR activity is changing. We then ran a Western blot, one of many, and all of these results are representative of the trends we observed in all of our collections, because we actually have 4 collections of 20-day hormone withdrawn cells. So we have days 0 to 20 up here. Our ARN20 is the antibody we use to probe the blot for full-length androgen receptor, and our beta tubulin is used as a loading control. So the androgen protein levels remain fairly consistent throughout the 20 days, even though it does look like it might be a little higher on day 6. But when you look at the loading control between days 4 and day 6, that's what accounts for it. So there appears to be no change in the androgen receptor protein levels among the 20 days. So androgen receptor protein levels appear to remain consistent, but the PSA levels are changing as an indicator of the AR activity changing. As a result of those, we looked for possible splice variants using 2 different antibodies, ARC19 and ARV7, and we stripped the blots and probed with these 2. Full-length androgen receptor falls at 110 kilodaltons, so the bands you see up here for the 20 days is our full-length androgen receptor. And we found lower molecular weighted bands, very distinct ones, appearing on day 8, and here at 75 kilodaltons. And then the bands disappear, and then a very distinct band appears again at 14 and persists throughout the remaining days. And we observed the similar trends using ARV7. Furthermore, we're also curious about any possible long-term effects on hormone-deprived cells. So we actually grew these LNCAP cells without hormone for 74 days. Here we have day 0 and day 20 for reference, and then day 30, 60, 70, and 74. These are also all at 40x magnification. And you can see the change in these cells that have been withdrawn hormone. The change in the shape remains throughout the 74 days. We also looked at AR protein levels in the long-term tangential study that we have. And so day 0 and then the last day of the collection, day 74, using our full-length androgen receptor antibody and the beta-tubulin as an internal control, or a loading control, excuse me. So beta-tubulin being comparable, the protein levels of the androgen receptor also appear to remain fairly consistent. So throughout days 0 to 20, and also for our long-term tangential project, days 0 to 74, the AR protein levels appear to remain consistent, unchanged. We also looked at the PSA mRNA levels, and day 0, day 70, and day 74 depicted here, PSA, and then GAPDH as the internal control. And with the GAPDH levels comparable, we see a dramatic decrease in the levels of PSA mRNA from day 0 to 70 and 74. But we can see that it's still able to be expressed. There are faint bands that appear here, although it's dramatically decreased. And to just ensure that our cDNA is good to begin with, we ran a cDNA test here with days 70, 74, and 0. And our cDNA test shows that our cDNA was successfully reverse transcribed. So the takeaway of this is that the PSA levels are changing, indicating the androgen receptor activity is changing. Our conclusions, our findings are consistent with other studies. We observe repeatable, sustained morphology as well in our cells, and the changing PSA expression levels throughout the collection is consistent with our preliminary work. Even though the PSA levels are changing, there appears to be no change in the AR levels. In our long-term withdrawal, we found that the cells are still able to survive for 74 days without hormone, and also that the morphology persisted without hormone for those 74 days. There also appears to be no change in the AR protein levels, but there is a change in the PSA mRNA levels, which indicates a change in the AR activity. So the summary is, we asked ourselves at the beginning, what happens to prostate cancer cells, the ones that are hormone sensitive, since there are hormone independent cell lines as well. So what happens if we deprive these cells of androgen? And we found morphological changes, reproducible morphological changes, importantly, induced splice variants, no change in the AR protein levels, but a change in the AR activity as indicated by the changing PSA levels. Our future work will be to stain our cells, excuse me, not stain our cells, to use neuroendocrine markers to confirm our findings of those morphological changes, and also to repeat the 74-day extended withdrawal, so the 30, 60, 70, 74 days without hormone, in order to validate whether our observations are reproducible as well. Our references, and Peter in the back over there. And there are too many people to not thank. First, Dr. Zhang has been amazing and a wealth of knowledge, and my committee members also who have been really supportive. And it didn't feel good not leaving people off, because my project was so time sensitive that at every point of the way, something, either we were out of supplies or it was I scurried around to all the different labs and asked if I could borrow items. And so there are just so many people to thank, especially for the training. I couldn't have done this without Peter or Lucia, Bill, who retired, Dr. Gorski, Don, who now is with Johnson & Johnson, Chris and Sarah, Kyla and Dr. Hein, and for answering all of my questions. And then I borrowed a lot of supplies for westerning from Dr. Appelt's lab, and Dr. Monty for all your expertise in the androgen receptor. Dr. Chen, when our hood broke, you let me use your hood and coordinate with you so that I could complete my project. Dr. Young, because all of our ice buckets went missing. And our ice machine also broke. And you lent me ice buckets and let me use your ice. And Dr. Hindley also lent me different internal controls to test. And so Dr. Bell also has been really supportive in making sure that I had everything I needed. And Sharia, first of all, always knows where Dr. Bell is. And she also is so great about making sure we as students have information that we need. And Deb at the registrar, she's the reason why I'm able to enroll in research to begin with and make sure all my financial aid is in check. And then my family who's here with me, my mama and papa So, there, and my sisters are flying, and then my fiance Ryan for always believing in me and pushing me, my biomed class friends, and so many of my PCOM parents. So all the love and support. And since I had such odd lab hours, PCOM maintenance and security were always really concerned about me when they saw me in lab at 3 in the morning. So they're always checking in on me, and so I have to thank them for that too. And Akuntra now, which is Cambodian for thank you very much. Yes. Yes. Right. Yes. Right. That's a really good question. I'm glad you brought up that point. Since we also retained total cell growth from each phase, there are other variables which cannot be separated other than withdrawing hormones. So there's also cell density to consider as well. What actually is interesting is that even though retaining total cell growth deviated from our preliminary work, our findings, though, are still consistent with other studies, various other studies, which seeded different amounts of LNCAP cells. In terms of reintroducing testosterone or other hormones to think about, and that being one of the many we could try, that's definitely something to consider for future work. Since this project, I had to do the 20 collections and then repeat those 20 collections first before I could analyze all of them, and then also the extended 74 collections. So each 20 collection period is about a month. But there was an interesting study, actually a few of them, I read that seeded like 8,000, 10,000 LNCAP cells each time, and they deprived of hormone. And they, first of all, they suggested in order to study the effect of antigen on LNCAP cells and withdrawing it, to study it for longer than 8 days. And they didn't say why specifically 8 days was encouraged, but that struck me as something curious since I observed in all of my collections at 8 days that change you saw in the more like the fine projections. And they also reintroduced hormone into their cells after a certain period. It was 10 days or it was something, and they didn't say why. They also did this project for 30 days. So when they reintroduced the hormone, they observed no change in the cell shape or cell size for the remaining 30 days. So that was something that was interesting, that was already performed by a few other studies. But when I was reading these papers, I was struck by the encouragement of specifically 8 days And then also, I was curious why they didn't mention they reintroduced hormone. Maybe they're curious about that as well. I would also not rule out speculation that perhaps as they were doing this experiment, they thought their cells were dying and needed hormone again, and that's a possibility as well, since there's a very drastic change that occurs where the cell literally looks like it's dying, and you're kind of worried for a bit. But does that answer? Oh yes, there's that as well. Yes, Dr. Young.
Very good presentation. I was able to follow it very well.
Thank you, I appreciate that.
I have a question that kind of follows up on what Aaron asked. Another way of, do you see or have there been any studies looking at blocking the receptor?
Yes.
Let's say flutamide.
Yes.
It's very specific, and you would expect there to be similar things. So, a little bit about that.
Yes, there are studies, and I actually wasn't able to attend Peter's defense, but I believe Peter looked at several drugs as well. That's something fairly recent, and actually the FDA approved what you mentioned, flutamide, for specifically targeting the androgen receptor and blocking it. And so there are some studies also, I'm trying to remember, not just flutamide, but enzalutamide and abiraterone. Also, abiraterone is for the enzyme, but, and they actually found that the survival improved, but then after a year, there was a relapse in the tumor. So this was also within the last few years. So it's still a new frontier, but it's definitely something being investigated. And I think that's the exciting, very sad but exciting study of prostate cancer, and especially castration-resistant prostate cancer, is because so much is unknown about it. It's such a phenomenon that we seem to be discovering something all the time, each year. And eventually, it'll get to a point where I believe we'll have some answers. I actually wanted to bring up an example of last year, Europe did the first ever pooled real-life study of men with castration-resistant prostate cancer, and they actually have almost 3,000 men enrolled from 16 different EU countries in order to study castration-resistant prostate cancer. And something like that is going to provide very meaningful evidence of not just in vitro things that we observe in the lab, but also in vivo and what actually is occurring in real life. So that frontier is definitely something very exciting to look forward to. Yes, Dr. Little. The interesting thing is that these splice variants were, first of all, a surprise. And it was very exciting to find. It was something I decided to just do out of sheer curiosity. And I decided to strip and probe with ARC19, which retains the C-terminal domain. And finding, let's get this laser, this very distinct band, if you can see it here, appearing on day 8, and then going away, and then again on day 14 through 20. Relating this back to what we observed morphologically, appears to coincide with these changes becoming established or taking place in these cells. So we see our day 6 and then our day 8, and the differences, the reproducible differences in the shapes compared with our control set. So there's definitely this warrants more investigation in order to determine contributing factors. But you know, it was an interesting thing to see a splice variant retaining the C-terminal domain. That wasn't something I expected to see at all, to be quite honest. But finding it and it's very shocking and very exciting. So there definitely will be future work. Right. The DNA. Well, the right. The DNA and then the hinge and then. Right. So right here. Right. So you losing this and keeping this. Oh, the ARV7, yeah. It's also interesting because finding one thing doesn't mean it's also mutually exclusive from something else. It's possible that there could be some sort of cooperation between the two, and that's something I can't conclusively say, but it is definitely something to investigate. Yes, Tina?
So for the future physicians in the room, did you see as the transition from side of the clinical implementation?
That is a great question, and there are a few future physicians in this room, so I'm happy you asked. Well, with the scope of research in prostate cancer changing, an important thing to know about transitioning from research to bedside is that there are many different implications for something, for a disease. For example, I mean, I guess this goes back to radiation surgery being effective, but also needing to educate the patient in the results of those and being very honest about what they might lose as an effect of undergoing surgery and radiation. It's not, nothing is ever an end-all be-all kind of cure because there's also quality of life to consider. So there are actually a couple different newer treatment options that I've read about that have come out recently, one being targeted lasers. And this one's actually interesting because you know, they dressed it up very nicely and it almost sounds like a miracle, but targeted lasers going in and being able to, instead of surgery, the option to target and select and kill only the prostate cancer cells which have become a problem, but leaving the other prostate cancer cells which are of low concern until symptoms develop. And then they would just continue doing, there's an option called active surveillance, which actually sounds odd that you wouldn't want to treat prostate cancer right away, but active surveillance is monitoring the cells until symptoms develop. A lot of times, you know, there's pushback in wanting to cut out, you know, very necessary nerves and structures. So the thing with what I mentioned about the targeted laser as an option, the patient would need to know what that really means. It's not necessarily a cure. It still means you're killing some of the cells, but you're leaving others that you're aware of until they become an issue. And then you would need to return for regular checkups because you're being monitored until those cells you've left have become an issue. And there's also that aspect of that quality of life, because so if you're aware that you're purposely leaving some cells and you're a patient and you know these are cancer cells, but you're told and you just have to trust that they're not a problem yet, but you have to return for regular checkups, what kind of effect is that going to have on your quality of life, your anxiety, your blood pressure? There are also comorbidities associated with prostate cancer as well. So those are all, factors to consider. So moving forward, and the importance of educating your patients on the honesty of what each treatment could imply, and also not looking at androgen deprivation as that end-all be-all cure. It's often used in conjunction with other therapies, but also being aware that you could overtreat somebody, and that can be very harmful. Yes, Dr. Chen. Thank you. Yes. For our purposes, yes, because there are derivatives of uncapped cells. We showed to interlude into that. The morphology that we found, uncapped cells have been shown to transdifferentiate, and so there are other variations of the uncapped cell line which are already hormone independent, and they remain hormone independent for indefinitely. So for our purposes, we're curious about the relationship between withdrawing hormone and then becoming hormone independent. So that's why we use the uncapped cell line, which is expressing the androgen receptor, but also sensitive to hormone. Yes, they did proliferate. Let me actually go back to. It becomes really apparent with our long term, because we have day 0 to 20, and maybe this might also be what you're referring to, or we observe, increased cell death and more of the spaces around the cells. Instead of, normally the uncapped cells are very adherent and they stick to each other. The half-life is fairly quick, and so with the 2 days, if you plate the cells, returning on 2 days, you would expect to see them double. And but the proliferation becomes very apparent with day 30, 60, 70, 74, because that means that the cells are able to go from this to these. Right. Yes. Yes. Right, yes. I actually did calculate the cell density. It's a little overwhelming to look at because there are so many numbers, but there is a decrease in the growth up until about day 8. And then there's an increase in the growth again, but also it goes back to, that's something to account for with the splitting and the cell culturing aspects, since the cell culturing timeline accounted for total cell growth into each one to ensure we had enough for all the 20 days. So the densities were calculated based on the previous proliferation period. So again, this also goes back to accounting for variables which cannot be separated. So that's definitely, for the future, in repeating all 74 days, ideally, we would want to do what we did and also have another set as well with a certain number of seating, and that would also be able to have us more effectively compare the densities throughout the. No, thank you. I'm glad you brought that up. That's a good point.
Anybody else? So maybe to further answer the last question. So basically, we really want to focus on the turning point from 0 to 15 for Peter today. And for the long term, like a site for that. We try to build now. So basically, these kind
Yes, Dr. Little.
I guess it comes back to my question with splice variant. It's almost a time where you see the transition.
Yes.
Properties as well. Like
Yes.
in terms of changing technology.
Yes.
The cell's actually going through a kind of crisis. Switching that from
Yes.
switching over to
Yes.
an androgen receptor that's independent from hormone, hitting them with hormone after that point.
Mhm.
That's where
It would be interesting.
because now they're switched to it
Right.
as opposed to
Right. It would be interesting. It's also, you know, the transformation and the survival of these cells without hormone also indicates the selective pressures that the cells are going through. So the cells that die are dying, and then the cells that are able to proliferate without androgen, of course, they'll keep proliferating without androgen. So it would be interesting to reintroduce hormone when we notice that turning point happening for our own purposes of catching, as you suggested, what also might be going on, or trying to find other possible variants that can contribute. Okay. Thank you so much, everybody. I guess we have some goodies, cake back at our lab, refreshments. Thank you, everyone. I did it.